All right, so today our lesson is on section 1.4 of the textbook, which is transformations of polynomial functions. Now, we've talked about transformations back in grade 11 and grade 10, and also we did during our review days, we went over transformations. So there is really nothing more to it than what we've already talked about. So today's lesson should come as more of a review as well, especially for those of you who struggled with it a bit. Okay. So the polynomial function, power function, has an exponent n, right? So that could be like a power 2 for quadratic, power 3 cubic, power 4 for quartic, and so on. Okay? So the general transform function of a power function, of a polynomial function, is y equal to a times k bracket x minus d, whole thing to the power of n plus c. Now, as I've mentioned before, whatever is outside of these brackets, so c and a, those are affect your y value, so those are vertical stuff. And whatever is inside here, which I'm showing with the green here, k times x minus d, that's what's happening horizontally. Okay, so let's go over the item and you can fill out the basically the handout. So a is, as we all know, is a vertical stretch or compression. So if the value of a is greater than 1, we have a vertical stretch by factor of a. If the value of a is between 0 and 1, then we have a vertical compression by factor of a. And if a is a negative value, it has a negative sign in front of it, then you have a reflection over the x-axis. Okay, so we kind of separate the negative sign and the number itself, right? Now, k value, the next item, so we have it here, that's a horizontal stretch or compression. So again, now something about k is that it's always going to be a factor of 1 over k, so it's the work opposite of a. So if k is greater than 1, then you have horizontal compression by factor of 1 over k. If you have k between 0 and 1, it's a horizontal stretch by factor of 1 over k. And if k is less than 0, then you have reflection over the y-axis. D is the horizontal translation, horizontal shift. And remember, the format is x minus d. So if you have x minus 4, for example, then that's a positive value for d. And that means it's a shift to the right. So if d is greater than 0, for example, d is 4, so you have x minus 4, then it's d units to the right. And if d is less than 0, then it's d units to the left. For example, if d is negative 5, you will have x minus negative 5, which is really x plus 5. So that's a shift to the left. And finally, c is a vertical translation. So if c is positive, you're going upward c units. And if c is negative, you're going downward c units. Now, one thing that is very important is that the order that we apply this transformation is the same order as BEDMAS. So first, we need to do anything that gets multiplied by. So all the stretches and compressions, whether vertical or horizontal, it doesn't matter which one you do first, because they don't really affect each other. One is affecting the x coordinate, the other one is affecting the y coordinate. But first you do all the stretches and compressions, and then you do the translations. Okay, so we first do a and k, and then we do c and d. So let's look at an example. It says the graph of y equal to x cubed is transformed to obtain the graph of y equal to negative 3 bracket 2x minus x plus 1 to the power of 3. So you can see it's a cubic function, and plus 5. State the parameters and describe the corresponding transformation. So what's our a value? A is negative 3. So let's see, what does this do? It reflects over x-axis and a vertical stretch by factor 3. Okay, don't say a vertical stretch by factor of -3 because the factor is 3. That negative just makes it reflect over the x-axis. So that's my a value. My k value is 2. So what does that do? Is that a compression or is that a stretch? Correct, it's a compression because for k, it's the factor 1 over k. So it's a horizontal compression by factor 1 over 2. So that's my k. My d is, what's my d value? Correct, it's a -1 because this is x plus 1, meaning that it was really x minus -1. Okay, so my d is -1, and that's a horizontal translation one unit to the left. And finally, our c value, which is 5, which is a vertical translation, 5 units up. Okay. So now we're gonna apply. We're gonna try to graph it. So this is a cubic. So the original function was y equal to x cubed. Okay. So we're gonna apply mapping because whenever we are talking about transformation, we're gonna talk about mapping. So we're gonna map the points on the original y equal to x cubed. So those points are, and we generally do a 3-point or a 5-point mapping. So 5-point mapping is more accurate, it's better, we have more points, especially as, like, if it was a quadratic, 3 would have been enough, but as the degree goes higher, it's better to have more points. But 7-point mapping, that's redundant. So we generally do a 5-point mapping. So the points on the original graph are -2 and -8, because -2 cubed is -8, -1 and -1, 0 and 0, 1 and 1, and 2 and 8. So we're gonna apply this transformation. Now, if you want, you can apply all of these in the one step and do them, okay? Or here, I'm just going to show you in different orders of things. So as I said, first I'm going to apply the compression and stretches. So first I decided to do the horizontal. Now, I could do horizontal and the vertical in this one step, but let's do it to avoid confusion. Let's do it all separately. And then you guys can, but you don't have to do them separately. That's what I'm trying to say. So if you have 2x, so I'm just going to do the horizontal compression by factor of half, meaning that I need to multiply my x-coordinate by half. But my y-coordinate is going to stay the same as before. And -2 times half, that's going to be -1. So my new point would be -1 and -8 by just applying the horizontal compression. Then let's apply my vertical stretch and also the reflection. So I now have the point -1 and -8. So my x-coordinate is -1, but now I'm going to apply the vertical stretch. So I need to multiply my y-coordinate by -3. So it's going to be -8 times -3, which would make this -1 and 24. Now that I have these, let's apply my horizontal translation and my vertical translation. So I'm gonna subtract 1 from my x-coordinate because I'm moving it left. So it's gonna be -1 minus 1 And I'm gonna add 5 to my y coordinate because I'm moving it up 5 units. So it's gonna be 24 plus 5, which the new point would be -2 and 29. Okay, so spend a couple of minutes to fill out the rest of this chart, and then so pause the video, and then you can check your answer. All right, so these are the remaining points. Make sure that you get all of the third column, all of these as your final points. Okay. So basically, to get that, as I said, like you can just get them in one step, and you can just do essentially what we do is that it's it's x over k plus d and ay plus k. So this is essentially what you're applying to every point to find it. Okay. So these are the points, -2 and 29, which I showed you. The next one is -3 over 2, or -1.5 and 8, -1 and 5, -0.5 and 2, and 0 and -19. Okay. So now you need to try to plot these points. So draw a graph, the general cubic function, the original one, using the original points, which are given here, and draw the transform function using the final points. Okay, and let's have a comparison with them. So again, pause the video, draw your graph, and then you can check the graph with what we have here. Okay, so these are the graphs that you will get. So as you can see, the blue graph, that's your original cubic function, y equal to x cubed, and the green graph, it's the graph of our transform function, which is -3 times 2 bracket x plus 1 all to the power of 3 plus 5. So you can see that it has the reflection, so it's now with a negative leading coefficient that's from quadrant 2 to 4. And it has the compression and the vertical stretch and all of that would affect that. You can see it's more squished, basically, our graph than the one before. And you can see that this place here is essentially where in the original graph we had this cubic part. So you can see it's more vertically stretched and horizontally compressed, and it has moved to the left and moved up as well. Okay. So now let's get some other examples and getting the actual equation. So the example says describe the transformation that must be applied to the graph of each power function f of x to obtain the transform function. Write the transform function and state the domain and range. Okay. So I'm gonna do part A as an example, and then you guys can do part B yourselves, and then you will check the answers. So describing the transformation, so what's happening, so you can see it says that f of x is x cubed, and our transform function is y equal to 2 f of x minus 3 minus 4. So let's try to write what each of our values are. So my A is 2, which shows vertical stretch by factor 2. My K is 1, so I don't need to write that. My D is 3, so horizontal shift by 3 units to the right. And my C is -4, which is vertical translation 4 units down. Okay. So my equation now gonna be y equal to, so as I said before, all the vertical stuff, so A value and C value are gonna be outside, so it's gonna be 2, and you're gonna have the -4 outside. Now, that cubic function, the exponent 3, gonna affect whatever is affecting your horizontal. So here, the only thing I have is my D value, so it's just gonna be x minus 3, and then that's going to be to the power of 3. Okay, so that's my equation. Now, look at, try part B yourself. Just one thing that you need to note, and many of you made a mistake on your review quiz, is that this 2 here, you need to make sure you factor it out first, because x is always need to be by itself, so that needs to get factored out, which would affect your horizontal translation as well. So do part B yourself. Well, actually, the question asks for domain and range as well. This is a cubic, so we know that the domain and range is all real numbers. So my domain is x is an element of real numbers, so from negative infinity to infinity, and my range is y is an element from negative infinity to infinity. Okay. So do part B, pause the video, and then you can check your work. All right, so the A value is -1, K is 2, D is -3, and C is 1. You can see the factor of the 2, as you can see here, and that would affect my final function the way you can see it. Okay, so check your work there. Now for domain and range, well, this is a polynomial function, so we know that my domain is all real numbers. So x element from all the way negative infinity to infinity. Although for range, because this is a quartic function, the range is not all real numbers. But what you can see is that really I have a vertex. This is really look like a quadratic. The only difference is that this is a 4 instead of a 2. But still it has that vertex at really -3 and 1, right? So my range would be y, basically element of real numbers, but it's going to be every value less than or equal to -1. So from negative infinity all the way to, sorry, +1 with the square bracket. Okay? And that's it.